Okay, everybody. Hi, it's me. I'm back. Week 2 of Theory of Knowledge 1. Um, Still in the virtual hellscape that is our present day reality, but we're going to make it through and do the best we can. Um, I'm going to be honest with you guys, fresh off the bat. I'm struggling to figure out how to do TOK effectively in a virtual environment. TOK as a class is not supposed to be product driven. It's not supposed to be about doing a bunch of assignments or things like that. It's supposed to be about exploring ideas together. Um, I've always liked to think of it like a map, right? And we're just kind of exploring the map together. I don't necessarily I know kind of where our vague destinations are, but I'm supposed to be on the journey with you guys. And it's supposed to be through a facilitation of bringing something in for you guys to experience, to think about, to mull over, and then for us to kind of process through it together. And that has been more than a little bit of a struggle given our current interface. So, knowing that, all that we can really do is the best that we can do. I understand that it's not ideal, and I feel terribly about the fact that you guys are not getting the experience that you're probably supposed to be getting from this chorus or from your IB education as a whole. But all we can do is kind of keep on keeping on. So, um, real quick about first 9 weeks. Some of you guys did very well. Had some people that are going to have grades over 100 by the time that we get the grades finalized in Infinite Campus. Some of you did very poorly and really struggled to get anything turned in. I have to meet with my principal about what content recovery options look like for the IB program. Um, and whether or not we're going to offer them for IB, so on and so forth. The biggest thing to understand about the IB and the way that I like to talk to explain to students is that there's no one individual thing that the IB asks for that is really hard or super arduous or is impossible to do, but rather the IB asks you to do moderately difficult things almost all the time. And if you start to get behind, it becomes very, very, very challenging to catch back up because you are behind and because we are expecting you to kind of keep on going on because there's always more stuff to do. I'm going to try and do a better job this 9 weeks of trying to find the balance between what the district is asking me to do with giving you guys a reason to log in and giving you guys a reason to submit things every week, but then not giving you just busy work. And this is it's a hard line to balance. I hate the idea of busy work. I have long told my students that you should avoid education that feels like a checklist where I do this, I do this, I do this, and then I must have learned something, because that's not how education is supposed to work. But sadly, that's what online education turns into a lot of the time is just kind of a series of checklists. Um, so I'm going to do my best to try and navigate that this 9 weeks and see if we can't find at least a better kind of middle ground forward. So this 9 weeks, we are going to start discussions around science um, and what science is and how we approach science. And actually, hold on, let me grab something real quick. All right. You probably don't know this about me because I'm an English teacher, but I'm also a published scientist. Here's the book that I published. It's my scientific research. It is the riveting title of The Impact of STEAM Educational Models on Key Leading Indicators, Teacher Engagement, and Teacher Confidence. And it was a scientific study that I had to do for my doctorate degree. While I am an English teacher and a poet and a nerd, I am also very, very, very much in love with the sciences, and particularly the sciences as they are meant to be, not necessarily as we teach them. sadly, I think when you guys think of sciences, you think of sciences like the class, like biology or chemistry or physics or whatever, and that's not really what science is supposed to be. Science is simply a process for pursuing truth. Um, that is what science is. It is a method. It is a methodological approach to trying to achieve objective truth. Um, Now, there can be a lot of discussion and a lot of debate over whether or not objective truth is even an obtainable goal. And that's actually one of the things that we're going to talk about this first week. I posted an article. Some of you have actually already read it, called the post truth. Well, it's about the post truth era that many people say that we have entered into now, and how fitting a description that is. But science is the pursuit of truth, and the idea of science is that I have an idea, right? It starts with that hypothesis, with that idea, and I'm going to come up with a way to test that idea to see the quality of truth that that idea has. And this is where things get interesting. When I'm testing it, I'm actually trying to prove that my idea is not true. I want to prove the null hypothesis, right? And the null hypothesis is basically that this idea is nothing, right? That if I think that I'm trying to think of a good null hypothesis. If I think that the IB program does not benefit students. Or wait, no. If I think that the IB program benefits students and really helps them do better in college, right? I might write a null hypothesis that the IB program has no benefit to students, and that the outcomes for students in the IB program are exactly the same as students not in the IB program, right? And then I would go about trying to prove that null hypothesis, right? And I would gather a bunch of data and a bunch of like analytics, and I would track kids through their next couple of years of college after they've graduated, and I would do a bunch of surveys and stuff, and then I would try to gauge whether or not the IB program had an impact on students once they graduated. Which, by the way, I did that. I did that this last summer because we are up for authorization. Actually, let me see if I can find that real quick. You guys might be interested to know what those kids said, huh? Um, Anyways, I'll see if I can pull that up while I continue to talk to you. So, the idea of science is that science to is seeking truth. That is what science is ultimately trying to do. Um, but we teach it wrong, because when we teach science, we teach it like it's this content acquisition, right? Like you got to memorize the parts of the cell, and you got to memorize that mitochondria are the powerhouse, and you got to memorize the terminology and the labels for all these things. And I think that that's broken. I think that we are doing things fundamentally wrong there, because we're not teaching you the fact that the root of science is really in questioning. That is what that is what science is supposed to be. Is it's supposed to be about asking questions and then pursuing the answers to those questions. Really quick, let's see. Let's see if I can pull this up quickly here, just so that way you can see it. And this is one of the ways that like we use the scientific process all the time in places that you would not expect, including as teachers. You know, as a teacher in the IB program, one of the things I have to do is I have to assess our program and its outcomes. And I do that scientifically. I gather a bunch of data and I look at the outcomes, and then I gather a bunch of student and teacher surveys. Where are we at here? These are the teacher survey responses. Student responses. How do you feel about the program implementation? Great, good, indifferent, bad, great, blue, good, red. These are the not greats, right? Cool. That's CAS. You guys haven't even started talking about CAS yet. Would you recommend the IB program to other students? Now, I should note that this was filled out by alumni, students that have already graduated and are in college. 93% yes, only 7% no. How would you describe the program's impact on you? 67% said great. Another 33% said good. Nobody responded in the indifferent or bad. And then there's a bunch of individual responses that we could get into here, where they actually talk about things if we want to, but we're not going to get into that. So that's kind of the idea here. So when we talk about the sciences, and we're going to talk about a lot of various approaches to science over the next couple weeks, and the kind of questions that science is interested in answering. And I think that you might be surprised because science these days is very interested in answering the things like, what does it mean to be a person? What is something? What is nothing? What is the nature of our reality? And while these may sound like religious questions or philosophical questions, they are actually scientific questions, uh, given our modern state of scientific advancement. So, real quick, this is what Lawrence Krauss, he's an astrophysicist, dealing specifically in quantum mechanics, and he has this to say about kind of like the nature of science and the goals of science.
Well, science is a mystery, I think, because what also people don't understand about science is that the questioning is often more interesting than the answers. That I often say, as a theoretical physicist, the two most exciting states to be in are either wrong or confused, and I'm in most of the time, both most of the time, because then there's more to learn. The reason we do science is not so we can have this little cabal of scientists with the secret handshake that says we agree to this set of knowledge, we don't want anyone to know about it, and it's not even right, but this is our ideology. Instead, what people don't realize is that the way to become famous in science is to prove your colleagues wrong. And so what you want to often do is confront mysteries. It's the mysteries that make it enjoyable. It's the not knowing. And we don't know if we'll ever, nor do we ever assume we know everything. I doubt we ever will. And that's fine. Just learning more about the universe is really what makes it satisfying. And each mystery we solve leads to mysteries that are even more exciting. So the progress leads to a universe that continues to surprise us. And I guess what I often tell people is that every day I'm surprised if I'm not surprised.
So I think that he does a great job here of kind of getting to the heart of at least how I conceptualize science. But before we get into really the nitty gritty of science and the kind of questions that science asks and things like that, I wanted to begin our discussion with the depreciation of science in modern America. I'll use myself as a personal example. I'm not that fantastically older than you guys. I got some years on me at this point. I'm not saying that I'm a spring chicken anymore, but I'm not so far departed from you guys, time wise or lifestyle wise. I spend my spare time playing video games, watching anime and movies. Like I, I my patterns of behavior are very, very similar to yours. But what is different, I think, from my generation to your generation, particularly, is our fascination and our curiosity. I grew up in the space shuttle era, which was very, very excited and motivated by what the future might entail as far as exploration and new knowledge, and kind of what the future of humanity was going to look like. And we had all this optimism regarding what we were capable of as people. I grew up watching Star Trek, the Next Generation, which is this really optimistic perspective on what the future of humanity looks like in a couple hundred years, where it's a utopian society and there's no more conflict and there's no more class inequality, and everything is just about pursuing knowledge for the sake of knowing things and trying to make the universe better. And I feel like that is a zeitgeist that is absent from our modern social collective conscious. Rather, in today's world, we are skeptical, we are cynical, we don't see the future as optimistic. We see it as potentially cataclysmic. If you look at what the production of most of our cultural output is, it's almost all like apocalyptic, dystopian. Everything is about the end of the world, or the world falling apart, or the collapse of society, or the purge, or these things. And there's very little optimism out there. There's very little out there that is about the world maybe getting better, or us solving problems in a meaningful way. And I wonder why that happened. And one of the ways, and one of the things that I'm interested in is this recent, in the last 10 years or so, trend towards scientific skepticism, right? And these are the flat earthers, these are the anti vaxxers, these are the people that think that the coronavirus is a hoax, these are the people that have a skepticism towards science, but are not actually interested in pursuing the answers to these scientific questions that they have. For instance, hold on. So, for instance, the flat earthers. There's a scientist back in the 70s named Carl Sagan, and he was one of the first. He's one of the first scientists that really went out there and really tried to sell science to the masses and explain difficult concepts in ways that everyone could explain. And he did a demonstration in the 1970s that explained how we knew that the Earth was round, and he did it in 2 minutes. Like, look, here it is.
Here's a map of ancient Egypt. I've inserted 2 sticks or obelisks, one up here in Alexandria and one down here in Syene. Now, if at a certain moment each stick casts no shadow at all, that's perfectly easy to understand, provided the Earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length, that also makes sense on a flat Earth. But how could it be, Eratosthenes asked, that at the same instant there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the Earth is curved. Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away that its rays are parallel when they reach the Earth. Sticks at different angles to the sun's rays will cast shadows at different lengths. For the observed difference in these shadow lengths, the distance between Alexandria and Syene had to be about 7 degrees along the surface of the Earth. By that I mean, if you imagine these sticks extending all the way down to the center of the Earth, they would there intersect at an angle of about 7 degrees. Well, 7 degrees is something like a 50th of the full circumference of the Earth, 360 degrees. Eratosthenes knew the distance between Alexandria and Syene. He knew it was 800 kilometers. Why? Because he hired a man to pace out the entire distance so that he could perform the calculation I'm talking about. Now, 800 kilometers times 50 is 40,000 kilometers. So that must be the circumference of the Earth. That's how far it is to go once around the Earth. That's the right answer. Eratosthenes' only tools were sticks, eyes, feet, and brains, plus a zest for experiment.
So what Carl Sagan is talking about here is how we knew that the Earth was round and roughly the size of the Earth like 3,000 years ago. This is not new information, and yet we find people that are still skeptical of it. I mean, Carl Sagan explains it with some shadows on a piece of cardboard on a television show in the 1970s, and when you watch it, it makes very simple sense, and yet people still doubt it. In fact, there was a flat Earth documentary about these flat earthers that go out and they are trying to prove that the Earth is flat. And they do this experiment. Hold on. And here we go. So these guys go out and this doesn't have the link to the video. Does this have a link to the video? No. Anyways, oh wait, is it on Netflix still? Beyond the Curve. Let's see. Beyond Yeah, Behind the Curve. All right, so at the very end of this, these guys are flat earthers, and they disbelieve in the roundness of the Earth, and they set out on an experiment to prove that the Earth is 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 flat. And I want you to watch what happens whenever they do their own experiment. This is only like a 3-minute clip. Ready?
Constructing a reality.
Somebody asked me, what if it turned out wrong? What if it was wrong? What if would you feel this sense of guilt if all of a sudden it was proved to be a globe?
You have a backup experiment. If you're seeing through this hole, through the next hole, and seeing the light at the backboard or at 17 feet off the water, the Earth is flat. If he's holding it up at 23 feet high and we're seeing the light, well, that's because the Earth's curved. So I should only be able to see it when it's at 17 feet. Okay, go ahead and drive down there, Enrique. You're going to hold the light there. Enrique, how high is your light?
17 feet.
I mean, it's as... we don't see you, Enrique. Lift up your light way above your head. Interesting. Interesting there. That's interesting.
So these guys devised an experiment to try and prove that the Earth is flat, right? And they end up proving that the Earth is curved because their experiment to prove that the Earth is flat doesn't work. It only works if the Earth is curved, and they have to hold the light up higher because of the curvature of the Earth. When that happens, they did a follow-up interview with these guys, and they refused to accept the results of their own experiment. And this is kind of where I want to start with our idea of thinking about sciences and thinking about the role of sciences and how we conceptualize science and how we view science culturally in our society, because it seems like we've hit a point where the process of science, the process of pursuing scientific knowledge is less esteemed than the process of disbelieving science, where we place more credence and more interest and more energy into disbelieving science than we do proving it. And this is the last clip that I want to show you. And this is Neil deGrasse Tyson. He's an astrophysicist. He's also the head of the Hayden Planetarium. He's talking about the role of science in America today. And I feel like it's pretty solid.
How did America rise up from a backwoods country to be one of the greatest nations the world has ever known? We pioneered industries. And all of this required the greatest innovations in science and technology in the world. And so, science is a fundamental part of the country that we are. But in the 21st century, when it comes time to make decisions about science, it seems to me people have lost the ability to judge what is true and what is not. What is reliable, what is not reliable. What should you believe, what should you not believe? And when you have people who don't know much about science, standing in denial of it and rising to power, that is a recipe for the complete dismantling of our informed democracy.
Let us demand that educators around America teach evolution not as fact, but as theory.
An increasing number of parents showing skepticism about vaccinations.
Voters have approved a ban on GMOs.
Call climate change unproven science.
That's not the country I remember growing up in. Not that we didn't have challenges. I'm old enough to remember the 60s and the 70s. We've got a hot war and a cold war, civil rights movement, and all of this was going on. But I don't remember any time where people were standing in denial of what science was. One of the great things about science is that it is an entire exercise in finding what is true. You have a hypothesis, you test it, I get a result. A rival of mine double checks it because they think I might be wrong. They perform an even better experiment than I did and they find out, hey, this experiment matches. Oh my gosh, we're onto something here. And out of this rises a new emergent truth. It does it better than anything else we have ever come up with as human beings. This is science. It's not something to toy with. It's not something to say, I choose not to believe equals MC squared. You don't have that option. When you have an established scientific emergent truth, it is true whether or not you believe in it. And the sooner you understand that, the faster we can get on with the political conversations about how to solve the problems that face us. So once you understand that humans are warming the planet, you can then have a political conversation about that. You can say, well, are there carbon credits? Do we do this? Do we put a tariff on it? Do we fund? Do we subsidize? Those have political answers. And every minute one is in denial, you are delaying the political solution that should have been established years ago. As a voter, as a citizen, scientific issues will come before you. And isn't it worth it to say, all right, let me at least become scientifically literate so that I can think about these issues and act intelligently upon them. Recognize what science is and allow it to be what it can and should be in the service of civilization. It's in our hands.
So what is interesting here is that science is the pursuit of truth, right? But that only matters if we as people are interested in truth. And so I think that one of the conversations that we can have before we start to get into the processes of science and the questions that science are like answering, or how we go about knowing things in science, before we do any of that, we have to talk about the role of truth in our society and in ourselves as people. So what I've given you to do, this task this week, is I've given you this article to read. It's called The Post-Truth Era. It's written by an author who wrote an amazing book called Sapiens, and then he also wrote a book called, I think it's called Deus, Homo Deus. Pretty sure that's the name of it. Let me be able to check it. Yep, Homo Deus. I read both of them. Excellent books. He's a historian that also looks at science. So I want you to read this article, and he's talking about the role of truth in our society, and the way that we deal with truth, and the way that we think about truth. And then I want you to answer some questions here. There's very few questions. I didn't give you many here. I'm not trying to overburden you the first week back. There's only 7 questions to answer. So answer those 7 questions, but I really want you to mull them, because when we come back next week, one of the things that I want to talk about is, what is the purpose of pursuing truth if we're not interested in truth? If the goal of science is to try and discover objective truth, whatever that is, doesn't that only matter if we as people are interested in objective truth? If we care about objective truth and having the same set of facts? And if that is not something that we as a species are interested in, then does that mean that science is fundamentally useless for humans and for humanity? And if so, then what does that mean and say about us? And so that's kind of where we're coming to coming next week. So that's all I've got for you guys this week. Is again just this introduction video, trying to get your wheels to start turning, thinking about science and maybe some like new ways, and kind of from a more pulled back standpoint, right? Less about the content and the nitty gritty, and more about like the objectives and the philosophies of science, right? And then about what the role of truth and scientific truth, personal truth, what and like objective truth is in our current reality. So that's that. I'll come at you next week. We're going to do some live class sessions next week. This week is hard for me because it's my daughter's first week back to in-person classes, and so drop-off times happen to clash right into our class time. But hopefully next week we can start having live class session meetings basically every class period. So less reliance on you guys watching YouTube videos, hopefully. So yeah, that's that. As always, if you have any questions, feel free to email me or hit me up on Schoology. Always happy to answer them. I hope you guys are relaxing. I hope you guys are trying to find a way to find peace in the midst of all of this. If you need me, if you need help, if you have concerns, please just reach out to me. You'll find I'm a pretty easy guy to work with. You gotta reach out to me, and you have to self-advocate and let me know what is going on. All right. All right. Have a great one, guys. Oh my gosh, where's my mouse? There it is.